Hi Year 6, it's Wednesday the 20th of May and here is your maths learning for today. Our learning objective is to understand and calculate the area of triangles and parallelograms. So this is going to be very similar to yesterday's maths learning, but we need to use some different formulas to help us find the area, which is the inside of the shapes. I want to start off by just looking at the different types of triangles, because this is really important to know where the heights, bases or lengths are in each of the triangles. So the first one is an equilateral triangle. This means that it has 4 equal sides and 4 equal angles, as we can see in the image. The second is an isosceles triangle, which means that it still has 3 sides, it's still a triangle, but 2 of the sides are the same and 2 angles are the same, as we can see from the image. The third one is a right-angled triangle. And in this instance, this is a right-angled isosceles triangle because these 2 sides are the same length. However, the right-angled triangle has one angle, which is at 90 degrees, and the other 2 also add up to 90. The longest side is called the hypotenuse. So that's going to be really important, not so much for Year 6, but for when you go into secondary school, it's going to be really important. Okay, and then the last one is a scalene triangle, which means all the edges or all the sides are of different lengths and all the angles are different. So it's a bit of a weird looking triangle. Okay, so yesterday we looked at a particular formula to help us work out the area of squares and rectangles, which was length times width equals area. It's really important for a triangle. It's a similar formula, but we're going to use length times height of the triangle, not the width of the triangle, but the height of a triangle, so how tall it is. And then when we've got that number, we're then going to divide it by 2. Okay, because if we were to chop this particular triangle off of this one and put it here, it would make a square or a rectangle. So that is why we divide our length times height by 2, because a triangle is essentially half of a rectangle or a square. Okay, so now looking at some examples of how we can put that formula into action. So I'm going to quickly write that formula down on the page, just so I don't forget how to use it. So it was length times height, and then we're going to divide that number by 2. So I'm looking at the first triangle here, and I can see that the length of the triangle is 10 centimeters and the height of the triangle is 5 centimeters. So I'm going to start off by doing the first part of the formula, which is length 10 times 5, which equals 50. So that would be the area. If that was a full rectangle, the area would be 50 centimeters squared. However, it's a triangle, so it's half of that. So I'm then going to divide that 50 by 2, which equals 25. So therefore the area of this particular triangle is 25 centimeters squared. And again, we still put the squared because it still shows us how many squares we can fit inside of this particular triangle. Okay, so now looking at the next one. The next one we're looking at is here, and I can see that the length of the triangle is 11 centimeters, and I can see the height. Okay, so this bit here would be the height going down here. So the height of my triangle is 8 centimeters. So using my formula, I do my length 11 times 8 equals 88, and then I'm going to divide that 88 by 2, which equals 44. So the area of this triangle is 44 centimeters squared. Okay, then going with my last triangle here, this one here, I can see that the length is 13 centimeters, and I can see the height here, this bit here, would match from this point directly down, so it's perpendicular with the length of the triangle. It would be 11 centimeters. So the first thing I'm going to need to do is length times height, sorry. So 13 times 11. So I might need to use a long multiplication method here. 3 times 1 is 3, and 1 times 1 is 1. And then we put our placeholder in. 3 times 1 is 3, and 1 times 1 is 1. We add those together. 3 add 0 is 3, and then 1 add 3 is 4, and then 1 add 0 is 1. So therefore, if this was a rectangle, the area would be 143 centimeters squared, but this is a triangle, so we now need to divide that by 2. Okay, so half of 140 would be 70, and then half of 3 would be 1.5. So therefore, if I add those together, the area equals 71.5 centimeters squared. So you will be coming across some numbers when you divide by 2. It's going to have to be a decimal number, but remember, if you're halving an odd number, it's going to end in 0.5. Okay, so now we're going to look at parallelograms and how to find the area of a parallelogram. So I always remember a parallelogram is kind of like a wonky rectangle, but it has some key features. So obviously, a bit like rectangles and squares, we use the formula length times width equals area. So in this particular case, for a parallelogram, as we can see here, to find the area, we need to find the base of the parallelogram and then multiply that by the perpendicular height. So a perpendicular is when two lines meet at exactly 90 degrees. So as we can see here, this would be the base of the parallelogram, and here we would have the perpendicular height. So we can see that this line would join at 90 degrees and this would join at 90 degrees. So it's not the length of this side. No. We're working with the perpendicular height. So this can be reduced down to BH, which essentially means base times height equals the area of a parallelogram. That is essentially all we're doing. So it's very similar to rectangles and squares. Okay, so now we're going to look at some examples of some parallelograms, and these are slightly a bit easier because it shows you the height of the parallelograms at the side. So usually this would be shown as perpendicular to the base of the parallelogram. So before we start calculating, I'm just going to remind myself by putting B times H equals area. So this is an area. I might put a little p just to remind me that it's a parallelogram. So B times H equals A small p. So I can see here the base of my parallelogram is along the bottom, and then I'm going to multiply that by the perpendicular height. So I'm going to do 12 centimeters multiplied by 10 centimeters, and then that will give me the area of my parallelogram. And I don't need to do any calculating, just mental calculation, because 12 times 10 is 120 centimeters squared. Again, still need to put the squared because it shows you how many squares fits inside that parallelogram. Okay, now moving over to this parallelogram over here, I can see that the base is 14 centimeters long, and the perpendicular height, which would be this one, which would be the same as if it was here, the perpendicular height is 7 centimeters. So 14 would be my base, and then I would times that by my height, which is 7. So 14 times 7. So I'm just going to use a quick short multiplication method for this one. So 14 times 7. 4 times 7 is 28, and 1 times 7 is 7, plus the 2 is 9. So therefore the area of this particular parallelogram is 98 centimeters squared. Okay, now finally my last parallelogram at the bottom. I can see my base all the way along is 20 centimeters in length. And the perpendicular height, so this bit would be the same because they're parallel. The perpendicular height is 6 centimeters. So using my formula, base multiplied by height, I would do 20 times 6. So I'm just going to do this mentally. So I would do 2 times 6 is 12, and then 12 times 10 is 120. So the area for this particular parallelogram is 120 centimeters squared. Ooh, even though these two parallelograms look different, they actually have the same area. Okay, and then finally here is your star activity. You can choose either your 1 star, 2 star, or 3 star. Have fun with finding the area of triangles and parallelograms, and I look forward to teaching you guys some more maths on Friday. Speak to you soon. Bye.